In this video, I'll be going over functions and function notation. So first, let's give a definition of a function. A function is a relationship or a relation in which each possible input value leads to exactly one output value. We say the output is a function of the input. So to illustrate this idea, let's look at an image. So we have three different relationships here. I'll just number these. On the left side of each of these, we have a series of x values, and there's an arrow pointing to something on the right, which contains all the y values. So we want to know, is each of these relations a function? In order to determine this, we need to make sure that each input only goes to one output. So in this first relation, each of the x values has a single arrow pointing away from it, and it's going to a unique y value. So we would say, yes, this one is a function. In the second relation, each of the x values has only one arrow leading away from it, pointing to a y value. Now, look at what's happening with x2 and x3. They're both pointing to y2. Now, this is actually okay because each input is only going to one y value. Each x goes to one y. Even though two of the x's go to the same y, that is okay. So this second relation is also a function. The third relation is not a function because in this case, x2 is pointing to two separate y value outputs. So we would say, no, this is not a function. One way that we can kind of conceptualize this idea is if you think about the way that people have birthdays. So let's say on the left column in each of these relations contains a group of people, so they each contain 4 or 5 people. And on the right side, we're going to say when those people's birthdays are. So birthday, birthday, birthday. All right, so in the first relation, we have 5 people. Each of them has a unique birthday. Okay, so no birthdays are shared. Each person only has one birthday. In the second relation, each person only has one birthday, and in fact, these two people, x2 and x3, share the same birthday, and that is possible and quite common. In the third relation, what this would be showing is that this person has 2 different birthdays, and we know that that doesn't make sense. So this is just an example to help us understand how inputs and outputs are related. So let's discuss different function notation. The notation y equals f of x defines a function named f. This is read as y is a function of x. X is the input value and y is the output value. We can also call x the independent variable. And we call y the dependent variable. And what these terms mean is the value y is dependent on whatever x value we pick. So let's look at an example of this. So suppose we have f of x is equal to x squared plus 3x minus 4. And what we want to do is we want to find f of 2. What this means is 2 is going to be the input value, is taking the place of x. This is the independent variable. So we're going to input 2 into the function wherever we see x. So we'd say 2 squared plus 3 times 2 minus 4, and then we just simplify. So this is equal to 6. So 6 is the output value when we input 2. Another way of thinking about this is 6 is dependent on the 2 that we input. All right, let's do another one. Now, in the first example, we said f of 2. we input a constant value. We can also input a different variable. So how about f of the letter A? Okay, so this just means we're going to input A wherever we see the x. There's not really much simplification we can do here, so we're going to end up like that. F of A is equal to A squared plus 3A minus 4. So when we are evaluating functions, all we're doing is whatever is inside the parentheses, we either had a 2 or an A. Whatever's inside the parentheses, that's what gets input into the function. And then we input that in and evaluate, simplify down to get the evaluation. Let's do one more with that same f function. This time I'm going to input a plus h into the function. So even though there's two terms, a plus h, that we are inputting, we still do it in the same way as we did the previous two examples. So a plus h squared, that means a plus h times a plus h plus 3. This 3 gets distributed here. So 3a plus 3h minus 4. Here, when I multiply these two, these are called binomials, I'm going to distribute the a into each of the second binomial and then the h. Another way that you may have heard this talked about is called foiling. So a squared plus ah plus plus h squared plus 3a plus 3h minus 4. And then I think we can simplify a couple of these terms. So a squared plus h squared plus 2ah plus 3a plus 3h minus 4. That's actually as far as we're able to go on this one. All right, so that's a simple way that we can evaluate a function at different input values when we are given the function in an algebraic form. So something like this is called an algebraic form. All right, now let's look at a function that is not written in an algebraic form, but is in a table. All right, so I have three tables here. I'm going to name each of these. Let's call the first one f of x, the second one g of x, and the third one h of x. Okay, so we want to know is each relation a function? All right, so f of x, is this a function? Well, does each input value go to only one output? Well, 2 only goes to 1, 5 only goes to 3, 8 only goes to 6. So we would say yes, it is a function. G of x, similarly, we have each of these goes to only one input. So even though 5 and 5 is a repeated output, just think of the birthday example. We have two people named -3 and 4 that happen to have the same birthday. So we would say g of x is a function. And then h of x, well, we have a problem here because 5 is going to two separate outputs. So that's a problem. So h of x, we would say, is no, not a function. All right, and then let's evaluate a couple different inputs into this function. So g of 0. Okay, so what we're going to do is we're going to go to the function named g, and we're going to input 0. Well, when I have 0 as the input, the output is 1. So g of 0 would be 1 here. F of 8, well, that is pointing to 6. So f, when we input 8, we get 6. G of 4 is going to 5, and so on. So you can see how this operates. We're not going to input anything into the h relation because it's not a function. So we're not going to be concerned with that one. One last thing we can do with these tables is suppose we said g of x is equal to not g of x. Let's do f of x. So suppose f of x was equal to 6. What this is saying is find x that gives an output of 6. So the output that gives 6 is 8. So we'd say x is equal to 8 in this situation. So it's kind of like going backwards. So we can go in either direction on these. We'll be talking about inverse functions later on, and that's kind of the idea, is what output gives us a specific input. All right, this example is one that's similar to what we saw previously. So we have a function h of x that's equal to x squared minus 7x plus 2. And we want to evaluate that at 4 different places, at -3, y squared, 12, and square root of 10. Why don't you pause the video and see if you can evaluate each of these. When you're ready, hit play and see how you did. So here are the answers for each of these. Hopefully this is pretty straightforward. The only thing to mention is on this last one down here, we just want an exact value. We don't need to use a calculator, so leaving this with the square root 10 is perfectly fine. We can also think about functions graphically. So let's look at 3 different graphs. The first thing that we'll talk about is something called the vertical line test. And the vertical line test says that if we can draw a vertical line through the graph, and if it hits the graph in more than one location, then we would say that the graph does not represent a function. So in the first graph, there's nowhere that I can draw a vertical line to hit the graph more than once. The second graph, I hit the graph in 2 spaces here, so that means that's not a function. Similarly with the third graph. So let's look at the graph that does represent a function. And let's call this function f of x. Okay, so suppose I want to evaluate f of, I don't know, how about 2 from this graph? So what we would do is we'd go to 2 on the x-axis, and then we go down to the value of the graph. So f of 2, it looks like the graph right here is about -1.2. It's hard to be precise on this one, but we would say f of 2 is equal to -1.2. Okay, so when we evaluate a function that is graphed, we use the input value along the x-axis, and then we trace it out to the value of the x, and then we see what that value is on the y-axis, so -1.2. And then the last thing I want to look at is just an example of evaluating a couple different functions. So say I have k of t is equal to t squared plus t. Okay, so the function is named k. In this case, the input is t. And I want to find k of a plus 3. So I'm going to input a plus 3 wherever the t is. And then I'm going to simplify this down. So a plus 3, a plus 3, plus a plus 3. So the first two are getting multiplied. We get a squared plus 3a plus 3a. So that's plus 6a plus 9 plus a plus 3. And then we can combine some like terms. 6a plus a is going to be 7a. 9 plus 3 is 12. So that's what we'll end up with here. And then let's do one more. All right, so this one we have h of x is equal to 15x plus 12. And it says to solve for h of x when it's equal to 37. So what we're going to do is we're going to take this 37, we're going to put it in here for h of x. So 37 is equal to 15x plus 12. And then we're going to solve for x. So subtract 12 from both sides, we get 25 is equal to 15x divided by 15. We get 25 over 15, which is 5/3, and that's equal to x. Okay, so that's kind of like what we saw previously on the table, how we can go in the opposite direction. to solve for x.